redox is pretty obvious there. A lot of times smaller little pieces of it. You've got to have basically a 2% coverage, but here we've got well beyond that.
So you need 4 inches of
it is.
What is this black stuff that's
well, it's
mineralization?
dark enough gray that it's almost black. Have you guys used the Munsell soil color chart?
Yeah, we have before. It's almost out.
What we're looking for color-wise here is 3-1 or less, basically. Chroma and hue of 3-1 or darker. Oh, great, thank you.
Is that for the rust? Or the iron? Is that for the iron 3-1?
Basically, it's iron that...
Any redox was 2%, at least 2%.
Those basically, that water table moving up and then dropping back down is basically those reducing and oxidizing conditions produces that rust like it would on any kind of ferrous kind of surface.
And it was 4 inches of...
the dark one.
For the dark one, and there's so many different ones, so many different things to remember. I don't want to get too much into the numbers with that stuff, but we need a 4-inch band beginning within the upper 6 inches of the surface. Now this is right at the top, so we've got the
organic soil.
It's due to organic matter decaying, but not completely decaying down.
The whole thing's not an organic soil, okay,
Just that first 4 inches.
It's a mineral soil. So
okay.
It's just that upper 4 inches that he's looking for a buildup of organic.
Okay.
Right. There's a lot of organic material basically coating that sandy soil there. The actual mineral components get coated by the organics. Color-wise, again, thinking, okay, this is the 3-1 chip right here, value of 3 and chroma of 1 or less. So it can be either this one or this one. That's the 2-1 right below it. I've got the color there. Another criteria has to meet is it's got to be coated 70%. So if you see a whole lot of salt and pepper in there, meaning it's not uniformly black, then you may not have that coverage you need. So there's several different components to make sure you got it. And even the best of the soil scientists, they have their little card with them that have all these hydrosoil these guys will go through here and then actually say, okay, well, we might have dark surface. And this one's a little bit older. It's called S7 versus I think a different one on your sheet. But it's got to be a layer 4 inches or thick, starting within the upper 6 inches of the soil surface, with the matrix value of 3 or less, chroma 1 or less. 70% of the visible soil particles have to be coated, and then the matrix immediately below. So basically, when you go from that very dark gray to this brown here, that's got to have a chroma 2 or less. That's a lot of little details to remember, and that's why most everybody carries these cards because there's so many different components.
That's like an indicator key, essentially.
What I think has happened here, the way these bands are, I think there's been some erosion down this hill and actually deposited some of this material in here. And that's why you got to learn. Redox typically doesn't happen like this, and some of the stuff we're going to see later is going to be more your classic sandy redox. This, I think there's definitely some oxidation and reduction taking place here. That's why you've got such bright colors. But I think there's also been some washing and maybe some of this orange parent material that we're seeing, because these layers, that top's not typically the way you see it. Well, because they're so uniform. A lot of times redox, we're going to see ones that are going to be better examples of it. They're going to be little red, rusty splotches, and a lot of times they're going to be around roots, or they're going to be just little, almost like little concretions in there.
The red aura?
Like stuff they get hung up on washing through the soil.
Well, it's not just a physical process washing, it's that chemical process.
Also chemical.
Yeah. And like almost every construction site, there's sedimentation washing down the hill. When you've got a slope like this, when they were building, almost certainly their silt fences, if they had them, blew out, and the stuff, when it rained really hard, washed down the hill and got into wetlands. And we see that everywhere. Looking at that layering, that would be my wild guess of why we're seeing that uniform layer like that right along there, and then same as here.
I've seen wetlands become orangish in color after a good storm down from a subdivision that we were framing in. all the roads went straight downhill, straight into the wetland, which means all oil, gas.
Keeps our enforcement guys busy. With all that,
So this level is just O to almost A or B? Would it be all the way down to the level B or C or?
we don't get into those the horizon stuff.
Yeah.
It's really not sure we're really just looking at colors for that.
Or just like inches, 6 inches, or 4 inches down? And
Well, we're typically going 10 or 12
No,
inches.
just wanted to leave it.
okay.
Oh.
So at this point, would you consider that a parameter yet, or?
Yeah.
Okay.
Going through it kind of step by step. I told you earlier, we definitely have vegetation criteria met, so we checked yes for that box.
Okay.
Where I dug this hole, that's a hydric soil there, just barely making it hydric. It's not
Yeah.
not strongly hydric like some of the ones you might see later, but it is hydric. Hydrology-wise, some of the indicators, that's on the first page of your handout. Some of those indicators, like saturation, I wouldn't call this soil saturated. It's moist, but saturated, you've got to basically look at it and see it glistening on the surface. It's not there. I dug down maybe 10 or 12 inches. There's no free water standing in that pit. That's one of the other ones that's got to have high groundwater table, high surface water. We don't have any surface water. There's nothing, no inundation there. So what we'd use for hydrology in a case like this, I would feel that would be a wetland where we dug that point. I'd rely more back on the FAC neutral test. It's one of the other hydrologic indicators we can use. It's one of the last ones on that first page in the list. And that's where we're looking back at vegetation. Even for hydrology, we can say, look, if you take out all the facultative species, you still have mostly wetland species. So with that one, it's a secondary hydrologic indicator. So we'd also have to have that one with one of the other secondaries. Like I looked back at the office and I saw this area was just soaked after a rain. It stayed wet for a while. Indicators that it's a wetland. So I checked yes on that box.
Okay.
And so I guess part of the point too that I've tried to make with these students in general is that even though you have a cookbook, quote unquote, for anything we do, it's still critical thinking skills for you to figure out what is taking place and whether, what factors are. You can't do this just check. You have to use your brain, you have to use your knowledge and your critical thinking skills to really come up with the correct answer.
Absolutely.
So would this be considered the boundary line now, or do you have to go back a little bit to figure out what your boundary line for the wetland is going to be?
If I was flagging this out, I would probably put my flag right about where I dug that hole because again, this isn't strongly hydric.
Yeah.
I've got the redox, didn't quite have the dark surface, still need one.
Okay.
And I had one hydric soil indicator. I had the vegetation. I probably would have put it right there because it wasn't strong. Now if this was full of muck and I had water filling up the hole, I'd keep moving back up the hill, digging holes until I found where I was comfortable. Okay, I'm really at that transition point between the uppers and the wetlands.
Okay.
That 4 inches is like your threshold on the top surface
It
of
is.
organic matter.
For dark surface.
For dark
And
surface.
it doesn't have to be right at the top. It only has to start this in the upper 6 inches. So that's why we want to go at least 10 inches deep because let's say the dark surface layer starts at 5 inches down. Well, as long as it's 4 to 6, that means
Okay, so what you're saying is it has to be within the top, that dark surface has to be within the top 6 inches of here. It has to be
at least the 4 inch band.
within the first 6 inches.
What would be on target within the first 6 inches? What would be on top of that organic matter? It might be duck material, but that's not actually the soil we look at. We're going to take off that duck material first, and all we're looking at is the soil. That duck is not really the soil material. So that's a good question because most of the time the dark surface is going to be right at the top. But occasionally you might have maybe a drought condition where because of this, the soil gets desiccated out because it's just been baking in the sun and it's so light, a lot of the minerals, the organic material has been burned out. And until you get deeper down, it's a little more insulated, then you have that organic material that makes that dark surface. So the top part, you might find it's going to be really light gray before you get down below there.
I'm so slow. Said this, but it said, you said 4 inch there starting at the first 6 inches?
Starting within the upper 6 inches. And I didn't want to get too much into the details of that because we'll be here all day trying to memorize those little details. But just to give you a feel for those two main ones to look at.
Is there any way that we could get a copy of that little sheet?
No, I've got an updated one. This is actually a little bit dated. I can email that to you.
I would have to memorize it all.
Yeah. I'm thinking I'm hearing a text question coming up.
Great. What was that question again?
Everybody get to see the monthly chart?
There's monthly charts floating around, a couple of them, so y'all look and see what he's talking about, the colors, you know, the chroma.